now after finding the velocity triangle or velocity diagram, we have to find out the acceleration diagram, and we will proceed with the acceleration diagram. Acceleration diagram. Acceleration diagram. We have to take a scale ratio for acceleration diagram because AR PQ is 6.25 meter per second square and AR QR value is 0.74 and AR RS is 1.42. So for the acceleration diagram, we are taking a scale as 1 meter per second square equal to 1 centimeter. Is it right, sir?
Yes.
1 meter per second square equal to 1 centimeter is the scale ratio. Okay. Scale ratio for acceleration triangle equal to 1 meter per second square equal to 1 centimeter will be the scale ratio. So first we should mark a point and name it as P dash and S dash because it is a fixed point. So we are marking a point with small letter with dash, P dash and S dash. S dash is a fixed point and we have to draw the parallel scale to the space diagram. Parallel scale in order to the space diagram we have to draw. So the P dash, Q dash, the value, the line is inclined in such a way you should draw to the same parallel to this line. We should draw a line P dash, Q dash and to what centimeter? 6.25 meter per second square is the scale for PQ. Okay, now you have drawn this Q dash, you have drawn a scale, and for this is a crank, so it is rotating in clockwise direction. So in the crank it will be only one direction, so there is only radial acceleration. But when we consider QR and RS, it has both. It is converting rotational motion into an oscillating motion. So it has the radial acceleration as well as tangential acceleration. So for this both we should draw radial acceleration as well as tangential acceleration. So QR is parallel, so we have to draw a parallel line to what scale? To 0.74. 0.74 we should draw a parallel scale and mark it as X. And we should take a perpendicular line for this and we should project a line like this. Like this we should project a line, and now we should once again this P dash and S dash is fixed, so we should draw a parallel line for this P dash and S dash. See, the line is like this, so we should draw a line from here to what distance? 1.42 and mark it as Y and we should draw a perpendicular line from here, and we should mark this point as what? R dash, and this we should join these both points and these both points, and now the acceleration diagram is formed, and we should measure the scales. AR/RS is what? AR/RS. You should measure this distance, acceleration of AR/RS.
5.6 meter per
5.6 meter per second square. And we should measure this value also, ARPQ. AQR.
4.4 meters per
AQR is 4.4 meter per second square. And that's all the value comes. So from this we can calculate angular acceleration, and alpha RS equal to ARS divided by RS. ARS divided by RS.
5.6
5.6. ARS equal to 5.6 divided by, what is RS value?
0.1125.
0.1125. So alpha RS will become as
49.77
49.77 radians per second square. That's all. This is the result. We should mark the result in the boxes. Okay, we should mark the final result in boxes. Okay, once again I will explain. Acceleration diagram is nothing but drawing a parallel lines towards the space diagram. And first we have marked the point P dash and S dash because it is a fixed, so we are marking it as a fixed point, and you are proceeding to draw a parallel line from PQ. Hence this line is like this inclined position. We should move the scale towards the acceleration diagram, and we should draw a parallel line. To what distance? To ARPQ is 6.25 meter per second square, and our scales ratio is also 1 meter per second square equal to 1 centimeter. So you have to draw it for 6.25 centimeters, and then hence this is a crank. It has only radial acceleration, as well as this connecting rod will convert the turning rotation into an oscillating motion. Hence it has both radial angle also and tangential also. Hence we have to draw a parallel line first. Hence we are proceeding to draw with parallel lines for the connecting rod QR. This line is inclined like this, so we are moving a scale towards here. And to what distance you are drawing? A radial of QR is 0.74. So you are proceeding 0.74, and it is converted to tangential. Hence we are taking the perpendicular line from this point, from the X point, and you are drawing this line. And we have to draw the parallel line for RS also. So we are keeping the drafter scale here, and you are typing it, and you are moving it to the acceleration diagram, and you are proceeding to draw for 1.42 meter per second square. The scale ratio is 1.42 meter per second square equal to 1.42 centimeter. You are proceeding to draw a parallel line for RS, and you're marking a point y and you're taking perpendicular line for this point also. Then the line will meet at one point and that point is R dash. Now connecting the P dash to R dash, we are connecting, and from R dash to dash also we are connecting, and we are measuring the values for this acceleration diagram and proceeding the acceleration diagram measurements from the acceleration diagram, and then from this you are calculating angular acceleration, that is A alpha rs equal to acceleration rs divided by rs from the space diagram. Then you are getting the angular acceleration for rs. It is 49.77 radians per second square, and that is what the result is asked. Angular acceleration, hence true. Okay, thank you.